Hi, Antonis here from HitShape. In this short introduction video, I would like to show you how to use a welding assistant AI inside our software. Let's start. We have this geometry, overlap joint, and first we need to provide some details about the welding setup. Material, trajectory, and process parameters. If you already know the laser power that is required for that process, then just put it here. Otherwise, the software can suggest some typical values for the current welding setup, and we can just confirm that by clicking on Tab. So we defined our process setup. What we would like to know now is whether we are expecting any defects after the welding. Let's just ask AI about it. Let's look at the response of the artificial intelligence to that question. So first of all, the AI model says that in general the laser welding is suitable for the current material and the current geometry. And for many use cases, that would be the whole review that you get from the AI. But since we are working with a pretty interesting material and pretty interesting geometry, of course we will have some challenges, and that's what the AI is trying to tell us here. So what we have here is that our material is very sensitive to cooling rates. Moreover, their weld path is not a line. It has corners, and in those corners the temperature distribution can be different. Here we also have thin and large parts to be welded, which are prone to buckling and distortions. In order to be able to review the process properly, the AI needs some missing information regarding cooling rates and possible distortions in the part. And for that, the AI suggests to perform simulations. So we can accept or decline. Let's accept it for the temperature simulations. The AI assistant just added all the required parameters for the simulation, so we can look at it. Here we have some basic values for element size and weld zone, heat affected zone, and base metal. We can just accept all those parameters, they look good, and we can start the simulation. So the simulation is ready, so we can look at the results. So what we really need in this case is their cooling rate. So we can clearly see that cooling rates are below 10 seconds, which is critical for the current material, and we have a very high risk of getting martensitic structure inside their heat affected zone. So what can we do about it? Let's ask artificial intelligence. So what we have here is that the AI clearly shows us that those cooling rates are not okay for the current material, and then first what we can do in order to avoid having those brittle microstructures in the final weld is to use preheating. So we can also ask to compute the preheat temperature and run the simulation again. That's the main idea of how their welding assistant AI works in the HitShape software. Of course, we can ask other questions here in there, like here, something like how long is the weld? Yeah, and we get a clear answer that the length of the weld is approximately 170 millimeters. That's it. Thank you for your attention. If you have any questions, don't hesitate to reach out. We would be happy to talk.